Alright, so we're working through understanding these three conversion factors. This video we're going to focus in on looking at the molar ratios that we get from coefficients of a balanced equation, and then also using that in conjunction with our other conversion factors that we've been using. So let's go ahead and look at an example. We have to start off with a balanced chemical equation to begin. So here we've got a balanced chemical equation. If you're just given an equation, always check to make sure it's balanced. Number one step. Because if you don't have it balanced, the answers are going to be wrong again. So let's go ahead and look at this one. We've got 1 mole of ammonia combined with 3 moles of hydrogen, and it gives us 2 moles of ammonia. Okay. So nitrogen, hydrogen makes ammonia. Now our first question says that we asks us how many moles of ammonia. So let's pull out that information. How many moles of ammonia, NH3, are produced if we start off with 2 moles of N2? So this is going to be straight using the coefficients to do molar ratios. So one thing that we want to do is we want to know how many moles of N2 there are for moles of ammonia, because that's the relationship we want here. We're going to get those numbers by way of those coefficients there and there. So let's go ahead and set up our little equation here. We've got moles of N2. We want to get rid of moles of N2. So if there are moles of N2 on top, where they have to be canceled out, they have to be on the bottom. So we have moles of N2. We want to go to moles of NH2. So that's what we're going to put on the top. Moles of NH3 rather, sorry. NH3, ammonia. So now we've got to figure out what numbers come in front there. Well, it's just the coefficients in the balanced chemical equation. So the coefficient of N2 is a 1. Remember, if there's nothing there, coefficient is a 1. We put a 1 there. Now let's look at the coefficient of ammonia, NH3. It's a 2. So we're going to put a 2 there. And there you're done. That's simply what the molar ratios happen to be. Now we can cancel out our units there and there. And what we end up with is moles of NH3. We multiply it out. We get 4. 1 significant figure, so we have 1 significant figure. Okay. Hopefully you see how that goes. We have 1 mole of our N2, and that we need 3 moles of our H2, and we've got 2 moles of our NH3. I'm just taking the coefficients there, and we can take any 2 of those, pull them out into a molar ratio. Okay, in this case, we use the first one here and the last one. Now let's go ahead and see if we can use this concept of molar ratios with some of our other conversion factors. And here I'm going to show you a little bit of a shortcut on how you can think about it and give you a picture of what to think about in your head. So if we've got a chemical equation written like this, we can actually write our grams of what we have down here, and we can put our moles on top. So if I have grams of ammonia, I'm going to stick it right underneath ammonia. If I have moles of ammonia, I'm going to stick it right over the ammonia. So it'll go with whatever compound it's above or below. Okay. Now let's go ahead and look at an example on how we can use this type of setup to actually solve a problem. So in this problem, it asks us for how many grams of N2 are needed to make 7.50 grams of NH3. So we're going to put down these things right where we said on our little table up here. So our question mark is the grams of N2. What we have are 7.50 grams of our NH3. So it's going to go line up right with whatever it is we're talking about. Now, we can't go from grams to grams. We just can't do it. So what we can do is we can think of this as there being islands. And there's water surrounding each one of these. we can't get from one to the other. Okay? The water prevents us from going from one to the other. But what we can do is we can form bridges. So this technique is called bridge over troubled waters. So what we can do is we can go from grams here up to moles. We can do that because of our molar ratio, or molar mass, right? Moles, grams, grams to moles, so it's molar mass. Then we can go from moles of one thing to moles of another thing because of our molar ratios. Then, of course, once we have moles of this, we can come down and get grams of that. So as you can see, it's bridge over troubled waters. You can get from grams of one thing to grams of another thing. Okay? Can't go directly because the water's in there, but we can do a bridge. Now, one thing to remember is that every time you do an up or down, we're going to be dealing with our molar mass. Doesn't matter whether it's on up or down, so it's molar mass on that side, it's molar mass on that side. Anytime you go horizontally in this figure, you're going to be using a molar ratio, which will be your coefficients of your balanced equation. Okay? So this sort of gives us a picture of our logic of how to go from one thing to another. Sort of like when I was writing out our logic in a little strip here with all of our problems. This one gives us a picture of how we're doing it. Okay? Just remember, bridge over troubled waters. So let's go ahead and do this. We know we're going to need molar mass for this guy over here. We're going to need molar mass for this guy over here. So let's go ahead and calculate those so that we have them when we need them. Nitrogen is 14.01. We have 3 hydrogens, which are 1.01 each. So we're going to end up with 17.04. And our units, of course, are grams per mole. And this is of the NH3. Okay. If you want to put that 1 in there, feel free. Then we've need the molar mass of N2 as well. So N is 14.01. We have 2 of them. So we end up with 28.02. And of course, the units are grams per mole. And this is for the N2. Okay. So here we've got those conversion factors. And the molar ratio we're going to pull out from the coefficients of our balanced chemical equation. So let's go ahead and set up this problem. We said first thing we need to do is go from grams to moles. And we're going to use the molar mass of that ammonia to do that. So we've got grams of ammonia on top. Where does it have to be to cancel out? Well, it has to be on the bottom. So we're going to put our grams of NH3 on this side. And the number that goes with the grams, we're going to put right down there, 17.04. The thing on the other side of the line, we're going to put on the other side of the line. So it's 1 mole of NH3. Okay, grams of ammonia cancels out with grams of ammonia. We have to specify what we're talking about here. Because, for instance, if we just put grams, we're not going to know what cancels out what. Because it's grams of ammonia, grams of nitrogen. Grams of ammonia will only cancel out with grams of ammonia. It does not cancel out with grams of nitrogen. Okay? So do keep that in mind. Make sure you keep your labels in. Okay? Now we're continuing back on this problem. We've got moles of ammonia. So now we said we're up here. We have to get it over to moles of N2, and we're going to use our molar ratios to do that. So we want to get rid of moles of ammonia, so that's on the top, so we know that that has to be on the bottom. What we want to go to is our moles of N2. So that's what we're going to put on the top, moles of N2. Now, the numbers that we're going to put in front of here just come from that balanced chemical equation. So we look, what is in front of the NH3? It is a 2. What is in front of the N2? It is a 1. Remember, there's no number there. It is a 1. Okay? That's our molar ratio. Moles cancel out. Now we're up here. If we stop now, we'd have moles of N2. But that's not what we were asked for, so we have to do one more conversion factor. We said we're going to do molar mass here. And we got moles of ammonia on the top, so we need moles of nitrogen on the top. So we need moles of nitrogen N2 on the bottom. And so we're going to use that conversion factor right there. And the thing that's on the other side of the moles of N2 goes on the other side of the line here, 28.02 grams of N2. Now those moles will cancel out. The only thing we haven't canceled out here now is grams of N2. And we check that is in fact what we were looking for. So now we can do the calculation. Alright, so let's put 7.5 times 1 times 1 times 28.02 divided by 17.04 divided by 2 divided by 1, and we should get 6.16637 on our calculators. Before we move on to the next one, we always want to do significant figures. So let's go ahead and do that. We have 3 significant figures here, 4 here. These are exact numbers. We got 4 here. So our lowest number is 3 significant figures. So I'm going to say we need 3 significant figures for this guy. We go 1, 2, 3. We go next door to find out if we round up or down. That 6 is above 5, so we're going to round up. So our answer is 6.17 grams of N2. Now there are a couple things that I want to point out that we did in this problem. One is the bridge over troubled waters. Okay, you can use that in any problem where you've got a balanced chemical equation. Okay? It helps us pictorially see what we're doing and when we're doing it in our problem. Okay? The other thing I want to point out is when I calculated the molar mass of ammonia, it was the molar mass of ammonia, NH3. I don't care what that coefficient is. That coefficient has no bearing on the molar mass. The molar mass doesn't change depending upon what chemical equation it happens to be in. Molar mass of ammonia is always going to be the molar mass of ammonia. So when I calculated this, I calculated 1 nitrogen and 3 hydrogens. So do not include the coefficient when you're doing molar mass. Okay. Molar mass is for the compound, has nothing to do with its position in the chemical equation. Okay. So that's number one thing that I've seen students get caught up on. So be careful of that. The other thing is making sure you get your molar ratios right in the problem. Okay. And those molar ratios, those numbers just came from those coefficients. Okay. Remember, if there's no number there, coefficient is 1. So hopefully working this problem through, you'll get some practice on the homework working these types of problems, and you'll get very familiar with using this bridge over troubled waters to help you visualize how to get your answer.